Hopefully after finishing the activity and comparing your answers with another group, you realize that despite the size of your circle, your answers should have been close to the same thing. That it didn't matter what 30 degrees, what 90, what 180, on what circle it was, when you did the divisions, hopefully you got relatively close to the same number. If we could do this with 100% accuracy, all of the numbers should have been identical. So that looking at the arc created by a rotation is a little bit different than looking at the size of the corner of the triangle. So it's a new way to talk about rotations. So we're going to work with this idea, and I'm going to work with a unit circle. So this is going to be a unit circle. So my radius is going to be 1. So I know that all these points, this point is at 1, 0, this point would be at 0, 1, -1, 0, and 0, -1. And the reason I do that is now I know no matter what rotation I do, R is 1. So when I take a rotation and I compare the arc of the rotation back to the radius, this is a new way of looking at an angle, because the more I rotate, the more arc I create. And by comparing it back to the radius, that takes away any differences due to just having a bigger or smaller circle. So now theta would be my rotation, and theta in radians, and I'm working on a tablet, so just bear with me, is arc length divided by radius. So that's like a formula that gives us the angle in radian. And radian is just kind of like a unit. Now, I'm going to work with some rotations. We know I'm going to look at theta, or a rotation of 360 degrees. So all the way around the circle. If I rotate all the way around the circle, my arc isn't a piece of a circle. My arc is a full circle. Well, all the way around a circle is called the circumference. And the formula for circumference is 2 times pi times the radius. So now if I go to my formula and I say, okay, theta in radians is the arc divided by the radius, because I'm talking about 360 degrees, I know my arc is a full circle. So arc is 2 pi r, so that's my A, and then the formula for radians say we divide by r. Hopefully you can see then that I can cancel out my r's, and it's equal to 2 pi. So 360 degrees is equal to 2 pi radian, or sometimes you'll see that as 6.28 radians, because 2 pi just means 2 times 3.14. So all the way around a circle is 6.28 radians. When we speak radians, we generally carry 2 decimal places because we're mimicking 3.14 that we use for pi. Even though that's been rounded and cut off a little bit, that's what we use. So that's what we're going to round to. I'm going to look at another angle that we know some stuff about. So I'm going to consider, well, what if we rotate 180 degrees? I'm still dealing with a unit circle, so my radius is going to be 1. But if I rotate 180 degrees, my arc is 1/2 of a circle. So then that's going to be 1/2 of the circumference, and the circumference is 2 pi r. Well, 1/2 of 2 is just 1, so that's pi r. So now theta is arc length divided by radius. That's how I do radians. But in this case, I have half a circle, so it's pi r divided by r. My r's cancel out, and 180 degrees is equal to pi radian, or 3.14 radian. And now I can use this, that 180 equals pi, to come up with a whole bunch of other ones. So let's say I wanted to look at 90 degrees. 90 degrees is 180 divided by 2, so therefore it's going to be pi divided by 2. 180 degrees is equal to pi radians. 45 degrees would be 180 divided by 4, so it would be pi over 4. So we have like a golden ratio that 180 in degrees is the same as pi in radians. So I can use this to do a whole bunch of conversions. Oops. So I can start with degrees and go into radians. So whenever I'm working with these, I want to deal with kind of my conversion factor. So 180 in degrees is pi in radian. This is in degrees, so it's going to go into my formula where the degrees is. So this becomes 180 over 135 is pi over radian. I'm going to cross multiply, so I get 180 radian is equal to 135 times pi. So then if I isolate the radian, which is telling me what it is in radians, I get 135 pi over 180. I have two choices. I can go to a decimal and go 135 times 3.14 divided by 180. So I replace pi with what it is as a decimal, and then I'm going to get my calculator out and just type it in. So 135 times 3.14 divided by 180. So it's going to be 2.35, which we will round to 2.36. It's 2.355, so that's why I rounded it. That's fine for M's. M's, you can always go to decimals. U's, sometimes you'll go to decimals. Sometimes you're going to work in fractions and lowest terms, because I'm going to reduce the 135 over 180. 135 or 45 goes into 135 3 times. 45 goes into 180 4 times, so it would be 3 pi divided by 4. If you did 3 times 3.14 divided by 4, you would still get 2.36. Negative 210. So that was A. So negative 2.10. I'm going to do 180 over negative 210 equals pi over radian. Then I'm going to cross multiply, so I get 180 radian. And you can't use just R for radian because R stands for radius. So we use RAD so that we know the difference. So now I get negative 210 over 180. M's, you can just go negative 210 times 3.14 divided by 180 to get. I have to do that in my calculator. 3.66 on and on, so it's going to be 3.66. U's, we'd go, well, 30 goes into negative 210 7 times, and 30 goes into 180 6 times. So if I reduce that into lowest terms, it would be negative 7 pi over 6. And then finally 270. And as you get comfortable with this method, you might be able to go right to, well, it's going to be 180 with radian is going to be the angle that I'm looking at with pi. The 180 always goes to the bottom. I'm going to reduce by lowest terms, and 90 goes into 270 3 times, and 90 goes into 180 twice. So my final answer is 3 over 2 pi, or if we were speaking decimals, it's going to be 4.71. I can also convert from radians to degrees. So I'm going to go 3 pi over 5. I'm going to do 2.51 and negative 3.18. So again, because we're starting with this, I'm going to, actually I'm not. I'm going to use the conversion factors over here, and I'm going to talk about A last. So this one, it was 180 over degrees equals pi over radian. So that's going to go with the radian. So I'm going to have 180 over degrees equals pi over 2.51. So when I cross multiply this, I get pi degrees is equal to 180 times 2.51, which gives me 451.8. Now I need to get this into degrees. Degrees never have pi in them. So I'm going to bring this pi to the other side, but I'm actually going to divide. So I'm going to do 451.8 divided by 3.14. And I get 143.88, so it's 144 degrees. Degrees never have pi, so when we do the math, we end up using 3.14. So for negative 3.18, I can start right back here, or I know it's going to be pi times degrees is negative 3.18 times 180. Whoops, sorry about that. Stop it. I'm fighting with this a little bit. I need my eraser. I need to get rid of all of this junk. So it's negative 3.18 times 180. So to get degrees by itself, I'm going to do negative 3.18 times 180 and then divide by 3.14. So 3.18 times 180 divided by, that wasn't 180, 3.18 times 180 divided by 3.14 is 182.29. So it's 182 degrees and it's negative. Now if I go back to A, so this was B, this was C, going back to A. I could convert, but this is 3 pi over 5. They want me to go into degrees. Hopefully you recognize that pi is just 180. So all I really have to do for this one is replace the pi with 180 because they're the equivalent in different units. Sorry, it's a different language. 3 times 180 divided by 5. So that would be 108 degrees. I can also show rotations on a unit circle. So if I have this, it's really important that you learn that this is 3.14 or a pi. 90 is half of a pi. So if I do 3.14 divided by 2, I get 1.57 or half of a pi. The 270 we already looked at. It was 3 pi over 2. We did a conversion factor in the first set of questions, but it's really 4.71. Each of these was 90 degrees. But now each of them is 1.57. 1.57 plus 1.57 brings me to 3.14. 3.14 plus another 1.57 brings me to 4.71. This was 0, but it's also 2 pi, which is the same as 6.28. So if I ask you to show pi divided by 3, well, a full pi is all the way over to this line. This is half of a pi. A third of a pi is smaller than half of a pi. It's going to be about there. So that would be pi by 3. I also kind of think about this if you want to get an idea. It's 180 divided by 3, which is 60 degrees. So that's how I kind of knew it to put it there. If they asked me to show 2 radians, well, that's 1.57 up here. That's 3.14. So 2 is going to be somewhere in there. So I'm just using logic. Just like before when we were doing the degrees, you don't have to get it exact. It's just showing where it is. If they asked me to show 7 radians, I'd go all the way around to 6.28, and then I'd need a little bit more to get up to 7. So 7 would be somewhere in there. If they asked me to show, trying to think, 3 over, I don't want 3 over 2, let's do 4 over 3 pi. Well, 4 divided by 3 is like 1.3 pies. So a full pi is to there, so that would be like 1 pi, because you could also go 1.3 times 3.14, because if you're working in degrees, pi is 180, but if we're still working in radians, pi is 3.14. So to get it, I could do 1.3 times 3.14, and it would be approximately 4.08, which is going to be somewhere in between 3.14 and 4.71. So it is possible to convert between degrees and radians, or it's also possible just to work in radians. But it's important to know that instead of looking at, if I look at a rotation, instead of talking about the size of this piece as compared to 1/360th of a circle, we're really talking about how much of an arc do I create. So the more rotation or the more degrees, the more arc I get. But radian concentrates on how much arc. If I go all the way around to 180, I've created 3.14 of an arc. If I go all the way around, 6.28 when the radius is 1, and we always do that because it will always reduce down anyways. So take a look at the homework. I will go over questions on Wednesday if you have any.